Hi everyone, welcome to one of the amazing big data project. So the project name is build an ETL pipeline using AWS Lambda, S3, S3 bucket, AWS Glue, and DynamoDB. So many of you have requested for big data projects like how we can build the ETL pipeline and all. So finally this project is live. So this project has implemented by one of my good friend. He's working in a company, okay, as a developer, and he's a big data developer actually. So he has recorded the entire projects. He's going to explain each and everything for this particular project. So make sure you watch till the end, and I will share the code in the description. From there you can get the code as well. So if you want to learn the entire ETL pipeline, guys, don't miss the session. Don't skip anything. Just try to watch from the beginning to the end. If you face any error, if you face any issue, so definitely you can comment in the comment section. I'm going to help you with that. So let's get started with this particular project, guys.
I'll give you the project overview. So we'll discuss project overview in this video. So what actually we are going to build into this project. So the requirement is quite simple. We have an API. So we have a API. So let me draw an API. Let's say this is a API that is going to give us a data. And this data we have to okay, so let me just try to delete it. I'll try to take a good image. So web API logo image. Okay, so we will have this API from where we will be getting a data into the JSON format. We'll explain like in detail like what, where and how I'm going to download this data. Then we are going to use AWS Lambda. So let's AWS Lambda. So using this AWS Lambda, we are going to download this data. We have this AWS Lambda, so using which we are going to download the data. Now using AWS Lambda, we can download the data, but if you're downloading a data, but you have to store it because this is a compute like processing kind of service, a serverless processing service. So you can write any processing kind of code, but it cannot store data for later purpose. So we need some storage system. So we'll use S3 bucket. It's again cloud storage from S3 like Amazon. So S3. Okay, we'll use S3 bucket and we'll store the records into S3 bucket. So this will be our one part. And then once data is stored into S3 bucket, we will use AWS Glue. So AWS Glue logo. So using AWS Glue, we will perform ETL jobs. So using AWS Glue, we are going to read data from this S3 bucket, and then we are going to store those data directly to DynamoDB. We are going to store the data into DynamoDB. So we'll store data into DynamoDB. So this is the pipeline that we have to build. So you'll get to see everything in detail, like how we are going to build it. Like, but I just wanted to discuss like why we are choosing this AWS Lambda or AWS Glue to design this pipeline. So let me write all these points one by one. So first point would be like why I'm doing this. The first is like AWS Lambda is serverless. AWS Lambda is serverless. That means that we don't have to manage server from our side, and if you don't have to manage server from your side, so your task will be reduced. Along with that, you only need to pay the time at which your code will be running, nothing more than that. So that is like will be able to save cost. So I hope now you are able to guess it, like why we are choosing AWS Lambda. And there is a limitation in AWS Lambda. If your code is going to take more than 15 minutes to download the data or process it, or any kind of operation that you are doing, it is going to take more than 15 minutes, then AWS Lambda is not a good choice. Then at that time you can go for AWS Glue or EMR or EC2, whatever compute resources you want, you can go for that. Next, why we are using this AWS Glue. So AWS Glue, again, it is serverless ETL tool. Serverless ETL, service by AWS. That means again our ETL job that we will write, we don't have to maintain server from our side, and whenever required we can run our pipeline, and required infrastructure will be provisioned from AWS, and your code will be executed and automatically the cluster will be removed. Here also we are getting the benefit of serverless, and we only need to pay at the time at which our code will be running. So I have now you got the good idea about like how we are going to design this pipeline, why we are choosing serverless. Again, in AWS Glue we are going to write Spark job. So Spark code we are going to write. So the source code that we will use, that will be Spark. Okay, so we will use Apache Spark to write this code. So as I'm from Python background, so I'm like quite familiar with PySpark. I've worked with PySpark, so we'll be using PySpark code to read data from like S3 bucket in AWS Glue, and write data to the DynamoDB. So this AWS Glue is nothing but it is just going to give you the compute resources on demand. So whenever you run your code, it is going to give you the compute resources like a Spark cluster where we are going to run our code. The code that we will write, it is going to run that code, and the result will be stored into DynamoDB. It's quite simple. I hope now you got the overview about the projects. With AWS Lambda, you can run your code without provisioning or managing server. If I want to say this thing in one line, that means it is serverless. So in serverless, we don't have to create or manage servers. It will be taken care by your cloud providers. There will be server, but you don't have to maintain it or create it. So that is the meaning of serverless. I hope you got the brief idea about what it really means by this word serverless. You pay only for compute time that you consume. So in serverless, the pricing model is very simple. You are going to pay whenever you are going to use it, else you are not going to pay anything. So that's the idea in any serverless. There are no charges when your code isn't running. So in AWS Lambda, you can upload some code and you only need to pay whenever your code is executing. And if your code is not executing, then you don't have to pay any amount. Now you can run any kind of code, you can write any kind of code, you can read file from S3 bucket, or maybe you can communicate with any database, or you can communicate with any web API. You can you can take the data, you can do some transformation, or you can write any business logic, and you can save your result in S3 bucket or database. Everything is fine. With zero administration. That means if you don't have to create any infrastructure, you don't have to maintain it, so administration wise also you don't have to worry about anything. It's simple, like just upload your code. Lambda takes care of everything required to run and scale your code with high availability. You might have heard these things like build and scalable application, highly available applications. Lambda takes care of that also. You only write your code, upload your code to AWS Lambda. Scalability wise, if your application need 24 GB of RAM, you can have that RAM. If you want to get 128 GB of RAM, that is also possible in AWS Lambda. You just change the configuration. I want to use 128 GB of RAM. It's feasible there. So scalability wise, there is no problem at all in with AWS Lambda. High availability means your AWS Lambda is always available to run your code at any time whenever you want. So that is the meaning of high availability. Now you can set up your code to automatically trigger from any other AWS services or call it directly from any web or mobile app. So now suppose if you have uploaded a code in AWS Lambda, you want to trigger it. There are so many ways you can do it. Either you can trigger it on a specific time, or you can also trigger it from AWS services, or you can trigger it, or you can configure it to capture to run on specific event that happens in your AWS services, or you can directly hit a URL and your AWS Lambda will be triggered and your code will be executed. Or you, like, there are so many ways you can run your code, so there is no problem with running your code. With this, I hope you got a brief idea about AWS Lambda. In next video, we are going to see the implementation, or we are going to write a small application in AWS Lambda so that you can see the implementation and you can learn that implementation and you can use it wherever you feel. One last and one note point I want you to give, I want you to pay attention here, that AWS Lambda cannot execute any code which is going to take more than 15 minutes. So if you're writing something in AWS Lambda, make sure that it is getting executed within 15 minutes. So this is all. See you in the next video. Hello everyone, I am Avnis, and in this video we are going to understand the requirement of application that we are going to design using AWS Lambda. So requirement of application for AWS Lambda. So our requirement is very simple. We have a web API which takes input from us. It requires two information from us: from date and to date. I hope the requirement is clear. We have web API. We have to supply from date and to date using this web API, and this is going to give us JSON data. Now what we want to write this JSON data to S3 bucket. Simple. We will have a web API. We'll pass from date and to date to this web API, and this web API is going to give us some data between this from and to date, and the same data we are going to write it into the S3 buckets. So this is our requirement that we are going to implement in AWS Lambda. So with this, it's quite simple. I hope you understood this requirement. In next video, we are going to see the implementation. So this is all for this video. Thank you. Hello everyone, I am Avnis, and in this video, we are going to see the steps that we are going to follow to implement AWS Lambda code. The idea is very simple. We have to supply from date and to date. In the first run, we will not be having any from date and to date. So what we will do, we'll take from date as it is. So we will initialize some from date from our side. So let's say I'm going to initialize 0101, this any date based on the requirement. In my requirement, I have to choose this specific date. So when first time I will execute this Lambda code, this is going to take this from date, and whichever date I'm going to run it, that is going to be a current date. So if it's today's date, it will be 13. Okay, sorry. It is going to be 2023-01-20. This will be our from date and to date, and this data will be downloaded into the S3 bucket. After 1 month, if I run it again, so this current date that we will have, it will become from date. So we will have new from date. That from date will be this one. The reason is because we have already downloaded the data between this interval, and I'm talking about after 1 month. So after 1 month, current date will be 2023 2nd Feb. That means like Feb 20th. So this will be my current date. So my to date will become this one. So now after 1 month, if I will run, I'll supply this date to download the remaining data, and this will be our approach. So after 1 month, it will keep on increasing. So in every month we are going to run it. So this current date will keep on changing, and we'll keep on downloading the remaining data that is available in web API within this month. So that's the idea. I hope you got it. Now if I am going to use this current date, because based on this current date only I am deciding this from date, so that means I have to save it somewhere. So we'll use a database, MongoDB database, where we will store this from date and to date directly. These two dates details, we are going to store it into the MongoDB database. And every time whenever I'm going to run it, first of all I'm going to fetch those data from MongoDB database. I'll decide my from date based on the last current date that we have here in MongoDB database, and then we are going to supply this from date and to date to web API, and we are going to download the data, and then we are going to dump those data to S3 bucket. With this, I hope you got the clear idea about how we are going to implement it, how we are going to provide from date and to date. Okay, open Google Chrome, search for MongoDB Atlas. I'm going to expect that you already know MongoDB. So if you don't know, please go through some tutorials. Still, I will just explain you like how we are going to get a URL for MongoDB Atlas. So I have already an account in MongoDB Atlas. I'm going to log in to my MongoDB Atlas. I'll get the URL, because without this URL we cannot communicate with MongoDB database, or we cannot insert any record into MongoDB database or fetch any record from MongoDB database. As discussed in the previous video, we have seen that we are going to store our from date and to date into the MongoDB database. Because of that, we need MongoDB database URL. So let's click on connect to your application. This is the URL I'm talking about. First of all, make sure that you are selecting this driver Python and version 3.6 or later. So this is the URL I'm interested in, my username and password. Now if you don't have username and password, how you can create it? So you can go to database access. Here you can create add new database user, and you can create your users. So you can follow the wizard and you can fill the form, and you will be able to get a username and password. I remember my username and password. I have my connection string, so I'll definitely use my connection string. Okay, once you have this URL, you can just copy this URL. You need to install an application if you want to locally like query your MongoDB database. MongoDB Compass is a MongoDB client software that you can connect, using which you can connect with your MongoDB Atlas, and you can query, or you can basically go through your database. So I have already connected with. If you have the URL and you want to connect with MongoDB Compass, you can click on new connection, and here you can paste your URL, copied URL. Provide your username and password here. So just remove this one, write your username, then remove this one and write your password, and click on connect. Once you connect it, it will connect to your database. So let's connect it. So I have already like connected, so I'm not going to do it again. So I have connected with my MongoDB database. As of now, you can see that I have already a collection name as finance and complaint. In this complaint database only, like I'm keeping this from date and to date details. When you will start, you don't have this one. I will also delete it so that we will fall in the same criteria. Finance. So what we are doing, we are going to create this finance database and collection as well. So you can see that I'm not allowed to delete it because maybe the user which I have logged in through, uh, he cannot delete it. So there is like permission you can give to the users. Just understand that this finance component, within that I'm going to insert these records. So as we discussed, you can see all these records. I told you like we will be having a from date and to date. So this is how MongoDB stores the records. If you want to see in the tabular format, you can choose the format. Here you can say that this is from date and to date. Okay, with this we are done. I hope you got the idea how we can get the MongoDB URL, and that was the like main intention for this video. In next video, we are going to use this URL and we are going to write some code to fetch latest from date, so that we can like latest to date, so that we can use this to date as a from date for the next run. So I will open VS Code. Once you open VS Code, you can just choose a folder wherever you want to save your like implementation or your project. So we'll open a folder. So I'll go to the D drive. You can try to save your code anywhere, wherever you want. So I'll create a folder name as AWS Lambda function or Lambda application. I'll just simply give a name, and within this folder we are going to save our work. So I have Conda already installed in my system. I can just check the version, which version I'm using right now. So if you want, you can use it. As of now, I'm using 22.11.1. So first of all, if you're starting any project, you need one environment in which you are going to work with. So let's create an environment. Conda create -p virtual environment. Python version we are going to use 3.9, and then I'm going to use -y. So within some time, this environment will be created here in this folder. We are going to write a code for that. Okay, so it is still creating this environment. Okay, so environment has been created successfully. So let's go and activate this environment. So activating environment is quite simple. Conda activate and virtual environment slash. So with this, you can see that now I have activated this environment. I will also try to install some intelligence software which will help me to write code. So you can search extension. Within extension section, you can search for Python, and it is going to show you some of the useful extensions that should be installed in your VS Code, and it is really going to help you write code efficiently. So as of now, I'm installing it. So what it is going to provide you, it is going to provide you IntelliSense, linting, debugging, Jupyter Notebook, lots of things it is going to provide you. We'll wait for some times. Okay, within that, let's create a folder name as LAM. We'll create a folder as Lambda function code. So we are going to write code here in this folder, and I'll create a file name as Lambda function. Make sure that you are also giving the name, same file name, lambda function.py. Okay, I think extension is installed. So once you will install these extensions, here in the bottom, if you just select any Python file, in the bottom you will find out whichever environment you have selected for the implementation. So you can click on that. It is showing recommended one. You can choose the recommended one, and also you can just check the path where it is located. So it's talking about this current Python version. So that is what we are also interested in. So that's why I will go for the recommended one. So now we have successfully selected our interpreter. Now it's time for us to implement the code, but we are going to work with like S3 bucket as well as MongoDB database. We have to install few of the libraries. So we'll create one file name as requirements.txt. Requirements.txt. In this file, I'm going to install one library named as pymongo srv, and we're also going to use boto3. These two libraries required for the implementation. So let's install these two requirements, pip install for now requirements.txt. So within sometimes this things will be installed. I'll just try to zoom it a little bit more so that it will be visible to you clearly. So I think it's installed now. So now let's write a code. So code is very simple. First of all, I will like we are going to provide these three information. So we are going to declare these constants. So let's import OS. So using environment variable, we will read the database name, collection name, and MongoDB URL so that we can connect with MongoDB database. Sometimes to connect with MongoDB database, it search for some certificates. So we have to dynamically provide that certificate. So it's quite simple. All we need is just use certify module and then just create a variable ca equals to certify where. So it is going to provide you the certify location. Okay, fine. Apart from that, I wanted you to make sure that your auto save is enabled. This one should be enabled. So there should be a check mark here, auto save. It is automatically going to save your all code that you are writing. So you don't have to save it from your side. So we have imported important libraries like JSON, PyMongo, Certify, OS, Boto3, and Datetime OS. This library is required as we will implement the code. You will be able to see it. Also, we are going to use one more library, that is the request, because we wanted to download something from web API. So we need some libraries using which we can communicate with that. So using request we can do that. So let's mention that request library in the requirements.txt file. So I'll just install it again. Pip install -r requirements.txt. So all these requirement libraries, like all the requirement has been satisfied now. So we need this URL. So I'll create a constants. So we have this URL from where I have to download this data. So this is the URL. Here we can pass to date as well as from date, and then if I will download the data, this data will be downloaded in the format of JSON, and we will specify the interval. So that specific interval data will be downloaded. Also, in which S3 bucket I'm going to save this information, those things also we are going to provide through the environment variable. So we have declared a few constants URL that is required. Now let's say I told you that if we are going to fetch data, like if I wanted to download a data, I need to know the from date and to date. So that details we are storing into MongoDB. So we need some way through which we can communicate with MongoDB. So I'll create simply a client variable using PyMongo library. This Mongo client is a class where you pass your URL and see a certificate location. So it is going to give you this client variable. Using client, you can communicate with your MongoDB database. That means you can read the data from MongoDB database, or also you can write data to MongoDB database. No problem with that. Okay, for the initial run, okay, when we will not have any record in our database, so we will make sure that we are using from date as 2011, first 01 and 01. When we have a date in string format and we want to create a datetime object from it, so we can use this strp time, where it accepts in first parameter a string format date. So this is my string, or the date in string format, we can supply it. Apart from that, it also expect in which format this date is specified. So like %y is going to represent like first 4 character is year, then there will be a hyphen, then the next 2 character will represent month, then again there will be hyphen, and then last 2 character is going to represent date. So using this, I'm going to create from date object. Now we have this initial date. Like if we have no record in MongoDB database, no entry, so we'll start with this specific date. But if we have already a entry in like MongoDB database, so last time the to date, whichever to date was used, we can use that as a from date. I hope like you remember from the previous video, as I told you, the previous to date will become a from date for the next run. So here we are checking, do we have this like a tables, basically a collection in our database or not. So collection name in client database dot list collection name. So this specific statement, this specific expression is going to return a list of collections present in this database. So we are matching this collection name. Is it there? If it's there, so we have written a query, find max date from to date. So there will be two date column. So whenever we will run our application, that from date and to date will keep on storing it. We will also store it into MongoDB database. So we need this to date. So we have written this query, and using this query. Okay, so this query actually we are not using it. So we are not going to use this query. We are directly like sorting records based on to date in descending order. So automatically, if I will find first one, so it is going to give me the latest to date. It's like you have a date column, just sort it into the descending order and then pick first record. So that will be your max rate. Okay, so we are selecting it, and in case there is possibility that we don't have any record, so if record is not none, like that means there is record, that we are getting some result from this query. If we are getting this result, so we will get the to date and will assign it to the from date. So if this part will not execute, if this record is not available, so this will be your from date. But if it is there, so your to date will become from date, and the date on which you are running this job will become your to date. And based on that, we are going to prepare this dictionary and we are going to return. So from date to date. So again, this from date and to date, I am going to typecast it into the format of string, where first 4 digit is year, then hyphen month, then hyphen date. Likewise from date to date. Along with that, I will also try to return from date and to date object, because this information I wanted to store it into MongoDB database. So I'll just quickly show you on my MongoDB database once again. So this is our finance database. Within that we have complaint collection. So here you can see that we have from date and to date. So we'll keep on inserting from date to date, and this to date will again become the from date for this one. Like here you can see that, so we have downloaded data from like this date to this date, but this to date will become next from date, and then a new date will become a to date. So likewise we can keep on entering the records. So it helps us to download the data incrementally. So with this function we are able to get this from date and to date. Next we are going to create a function which is going to save from date and to date in database. So save from date and to date. So you pass your data in the format of dictionaries, and by default I'll keep status as true. Here in MongoDB also you can see that I'm writing status as false. It's just a status whether this data was downloaded properly or not. So we'll mark the status as true. So if you are providing false status only, then false status will update. By default it will accept as true. Inserting records in MongoDB, it's quite simple. You use your client object of PyMongo, write your database name, collection name, then insert one, then pass your data. So this is going to insert a record into MongoDB database. It's quite simple. Now we have to write a code for Lambda handler. That this Lambda handler is a function which will be invoked by AWS Lambda, and we are going to return some values from it. So this is a template. This template code you will also get from the, whenever you create any sample AWS Lambda code in AWS, this is a sample code it will provide. This event and context will have certain information related to the invocation that you can fetch it, but in our case it is like we don't need any information from it, but if you want we can capture it, what information we are getting from it. So let's import a library, logging libraries. Using logging.info, there are so many classes related to like this is logging in module, and within that we have like lots of classes functions available there. We can use it, but we will use info just to monitor it. Like in case if you want to monitor it, let's say this is a result which we are returning, so I'll just try to quickly assign it to the response equals to this one, and I can just monitor it what information we are getting from here, logging.info, and here we can mention it response, and we can also specify some message. Here let it be object, from date and to date. So we are logging this information, but if whichever information we are going to save, we can also log it. So log.info, the given data we can log it, and write saving from date to date. Okay, so this we'll try to typecast it into the, so we'll use f string, and we are going to directly use these things here internally. So I'll just write data here itself. Same we'll try for this one. Okay, we can use f, and then I will return the response. Yeah, so this is done, this is also done. This is logging dot handler will first log this event information. So info, we can write event. Similarly, we can also try to log context. These things will be an object, so we are just trying to log it. Okay, fine. And I would suggest, if this is going to help us to understand what values we are getting from event and context, or we can directly use better if you go and just try to print it. Okay, it is not required. So you can write print and context. So event and context, we can just simply print it. So in the CloudWatch log, we will be able to see what values we are getting from here. Let's write first of all, as we have created functions, you just now know that we have these two functions. So if I want to download something from this URL, I need to know what from date I can use. So we will call this function get from date and to date. That's why we have created it. So we will call it get from date and to date. This is a dictionary, and we are interested in these values, not this keys. We are interested in these values. So I'll write this dot values. We'll get this from date to date, from date object to date object. Now then also we will make sure that our from date is not today's date. So it is possible you are running your lambda function on daily basis, like today's also. So we'll just quickly check whether our from date is similar to current date or not. So if you are downloading the data from today's only, so today's data you cannot download. So we are just returning, we are just writing the code for that. So here we have written like pipeline has already downloaded all the data up to yesterday. So no need to download it again, because your from date and current date is same. So and today's date will also become same. So there is no point. Or I can just directly use this to date. Okay, if your to date and from date is same, so you can just avoid it. If your to date and from date is same, you can just avoid it. Fine. By default, let's try to prepare the URL now. So we have this data source URL where we have this from date and to date keyword, which we have to replace it. So we are replacing this to date with the to date string and from date with from date string. So we'll get the exact URL. Next thing is that we are going to download this data using request module. So it's simple, just request.get. We'll get this data. Now what we want this data. So what we will do, we are going to get this data. So let's get these data. So in the downloaded dataset, we will be having this underscore source information. So like within these keys, we have like our data. So we have to find out first the exact data, and then using S3 or using Boto3, we are going to write these records into S3 buckets. So first of all, if you want to write anything using Boto3, so using Boto3, we are fetching, we are getting a reference of S3. Then we are getting the bucket name. Then from date to date we will use to create the name of file. And then we are going to save it. So put bytes. So it's quite simple. We are using UTF-8, using which we are going to write this information. So we have this finance complaint data, which we are going to dump it inside S3 object. So with this, we will be able to insert the record into S3 bucket. So this is all we need. So we are done with the implementation, and finally we have to save our from date and to date into we have to save it from date and to date to MongoDB database. So this is all we need. So what I will do, let's try to keep the date as 23 first, so it can download the data of this year. So we have like around 20 days data is there, so it will keep by default, it will start with this date and it will try to download the data. So with this we are done the implementation. In the next video I will explain you like how we can create a zip file which we can upload to the Lambda function. So in the next video I will explain you how we can create a zip file which can be uploaded to the Lambda, so that these codes can be run in AWS, and we will test it whether it is running in AWS or not, and if it works successfully, then this is all we need. We have implemented then the requirement that we have discussed in the starting. We are going to discuss how we can create a zip file which we can upload to the AWS Lambda function. So it's quite simple. You can also directly take a reference from the official websites. In their official page, they have mentioned it. So creating zip for AWS Lambda. Yeah. So if you wanted to do the deployment, so this is the steps that we have to follow, like how we can create all these things. It is given all the proper instructions using which we can create a zip file. I'll not go through this documentation because I already have a step, so I'll just quickly explain you. So it's a one command is mandatory, like without that command you cannot create it. So we'll discuss that command, and once it is done, we can start the creating zip file. So to create a zip file, AWS Lambda expect us to use a Linux platform. So if you are not using Linux platform, in that case, we have to, like, whether you are using Linux platform or not, it doesn't matter. we have to just write a command. So we have to write like pip install, then hyphen platform. We have to mention platform. Here we have to mention like many Linux. Make sure that you are typing exactly as I am typing, because if you don't type it, it is not going to work. Then we are going to specify the architecture of computer, that is 86 and 64. Then we have to specify target equals to, we have to mention that this function, this folder name where our code is available. So it's like lambda function code. So lambda lambda function underscore code, then hyphen implementation cp. Then we are going to specify Python version equals to 3.9. And finally, we also specify one more flag like only binary equals to colon all colon hyphen upgrade. In upgrade, we have to mention all the requirement.txt that we have wrote here. So we'll write pymongo ysrv boto3 and request. All this is 3 libraries it is required to mention, then hit enter. So within some times you will be able to notice that there will be lots of files created here in this folder. Okay, so you can see that there are so many files getting created. So all this file has been created now. Now it's right time for us to create a zip file, so we can open this folder. So let's reveal in File Explorer. So this is a function, this is a main files that is required to upload to the AWS Lambda function. So what we have to do, we have to just select all the file, then right click on it and compress to zip file. So it is compressing everything to the JSON format, like to the zip file. Yeah, it has been compressed. Now it is asking for the name. We can write like AWS application. No problem with that. AWS application. So this zip file we have to just upload to the AWS Lambda and our task is done. Let's go and try to do it. Okay, I will log into AWS. Okay, so in next video we are going to create this AWS Lambda service. This is all for this video. In next video we are going to log into AWS portal and then we are going to create AWS Lambda. Also we are going to upload the created zip file there and we are going to test it whether it is working or not. So step is quite simple. First of all, you log into your AWS portal. So it will looks like similar to this. Then we will search for Lambda function. So it will take us to this Lambda page. Then we can create a function, simple function. So function name we can write as a download data. Make sure that you are writing capital names here in each word. Also we'll specify we are going to use Python 3.9 version. Architecture wise, this is architecture what we are preferring. I'll create on this function like create function. Within some time these functions will be created for us. Okay, so now function has been created, so we have to upload our code. So here you can see that sample code it has given to us. Here it has given a function name as lambda function, and because of which we have also given the name of file as lambda function. It is asking for upload from .zip file or a Amazon S3 location. So if you, there is two way you can upload your zip file to S3 and you can point it from here, or there is another way you can directly upload from here. So we'll choose and we'll click on upload and we'll locate. So you know that we have created this inside this folder and this was a zip file which we have to upload. Okay, AWS application. So right now it is getting uploaded. So we have to wait for some times. Okay, now it has been uploaded. Now we are, I'll just quickly open the source code. You can see that we are using some environment variable here, 3 to 4 environment variable that we have to set first. So let's try to set this environment variable. So we will first set database name. We'll create a database name. So go to the configuration and we'll have option for environment variable. We can click and we can click on add environment variable. Database name, you can just mention anything. So I'll write like a simple database. Okay, then collection name, we can just write record. Okay, a name you have to choose from the code itself. Okay, it has to be exactly same as we have mentioned here. So we'll write collection name as a record, and then it is going to ask you for the bucket. So let's create a bucket. Okay, we have to create one bucket. So go to open S3 and just create a simple bucket. We'll go and just try to create a bucket. Bucket name I'll give as data 327030. I think this will be enough. And we'll simply click on create bucket. So bucket has been created and you know the name of bucket. So we'll just mention the bucket name, bucket 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 underscore name is data 327030. So we will have bucket and then MongoDB URL, MongoDB underscore URL. So URL, you know how to get it. So I'll just copy the string and I will use my URL. So with this, I'm done with these variables which is required for my project. Now it's time for us to test it whether it is working or not. But before we start the testing, I would like to increase the memory size. As I told you, it is highly scalable. As of now, by default, it is giving us memory of 128 MB. 128 MB. I want to use 1 GB, so I'll just write 1024, which is equivalent to 1024 MB is equivalent to 1 GB. And yeah, this is more than enough. Click on save. Permission wise, yes, we have to give additional permission. So this is a role. I'll open it because we wanted to write something to S3 bucket, so we have to give full access to S3 bucket. So what I have done, we went to the permission and then we clicked on this role name. So within this role we can attach policy. So let's try to attach one more policy. So here you can see that there is an option to add a permission. So attach a policy, search for S3. So we want to give S3 full access. So we'll click on attach policy. So policy has been attached with this role. So that means now this function has permission to read and write to S3 bucket. So with this we are done. We have also set all the environment variable that is required. And in case if you want to invoke your function using URL, this is how you can create a function URL. But right now we just wanted to test it whether it is working or not. And yeah, event name, you can give any event name. So we'll just write test event. Any information if you want to share, you can share it from here, but we are not interested in that. I'll just quickly save it. And if everything is fine, it should work. If there will not be any error. So right now we are executing this function. Okay, so there is some error. I'll check the logs. In this video we are going to fix this bug. In the previous video you have seen that we are getting some error, so we'll just try to check why we are getting this error and we'll try to fix it. So there is the log. We are going to first check the logs. What is the error? We'll click on this. Yeah, so we are getting error like task timeout after 3 seconds. So yeah, so this error can be fixed very easily. It's like configuration related error. In the general configuration we've given timeout as 3 seconds. We'll just try to increase it. So we'll write timeout to, let's say, 10 minutes. We'll save it. Now we will test this code again. So let's test it again. So it is showing that log succeeded. Yeah, fine. We'll also check in MongoDB database if something got created, the given database name or not. So we have created a sample database where we have created this local, and you can see that for 2023 to 2020 we have downloaded the data. You can see that now that means it is working fine. We have to also verify do we got data into S3 bucket or not. So let's try to check the data. So you can see that file got downloaded also, like it's around 20 MB of data which got downloaded. So I'll just quickly download this data. We'll try to open it. We'll see if it is okay. Yeah, so you can see that we have got data also here in this file. Lots of data we have. Okay, so you are like 20 rendering pause for line, like for long line of for performance. So yeah, we are getting the data, so no problem with that. So this is how we have to create a function, and we created successfully and it is working fine also. We wanted to, if you wanted to check the logs, you can click on logs and we can check the logs in AWS CloudWatch. So we'll just check the latest log. Okay, so event wise, this information you can see that lambda constants, like lambda context is there. All this information you can easily see it. That means our application is working fine. So with this we are done. In the next video we are going to add a trigger to run this pipeline on daily basis so that we can keep on getting data in S3 bucket. So every time whenever we download the data, we will have this from date and to date. So you can see that this file has data from 1st January to 20th January. Tomorrow file with this application, these functions will run and will download the 20 to 21st data. So this way we will keep on getting files here in this, and we'll just try to schedule it. So what we can schedule it for the weekly basis, daily basis, as we want. There is no problem with that. Okay, so this is all. In the next video we will see like how we can create a trigger. Thank you everyone. Hi everyone, I am Onis, and in this video we are going to create a trigger for AWS Lambda that we have created. So let's go to our Lambda. So this is Lambda that we have created. So I have created this event bridge which I have already deleted it. Okay, so this is what I have created it, and I have already deleted it. You can see that it's not found. I'll create another trigger. So whenever you go for a trigger, it asks for the sources, like how you wanted to trigger your Lambda function. So there are so many things by which you can trigger your AWS Lambda function, and we are going to schedule it based on timing. So we will use event bridge. We'll create a new rule. Rule name we can just write as download data weekly. Then description, if you want, you can write, or then we have to write a schedule expression. So here you can see that there are two ways of specifying this schedule expression. Either you can specify through cron or rate. So we will go through the cron. I'll copy this cron, I'll paste it here. So it is designed to run on every day at 17. Like first one is minute, second one is your, okay, if you don't know, you can just click on this. It is going to take you to the table to understand like what everything really means. So first thing is minute. So this first thing that you see here, it's like 0 minute. Hours is like at 17. Then there is a day of month, which means on which date in month it has to execute. If you can specify on this specific date, it can execute, and we are going to write the question mark so it can execute on any specific day. So month wise, on in which month you want to trigger. So we wanted to run in each month. Then again, day of week, from which day to which date you want to run. So we don't want to run it on every day. We only want to run it on, let's say, Monday. and then year. So we wanted to run it for every year. So this is how we are going to specify our cron. So with this we have specified at what time it should run. So let's click on add. Okay, parameter schedule expression is not valid. Okay, there was this page, I think. Yeah, it got created now and it is enabled. If you want to see the details, we can click on this and you will be able to see at what time it is going to trigger. So let's go to the local time. So on 23rd January, it is going to run at 10:30. On 30th, it is going to run at 10:30. So this is the date on which this function is going to be triggered, and the data will be downloaded on weekly basis, and those data will be uploaded to the S3 bucket here. Here we will have the files. So with this, I think you got brief idea about how you can use AWS Lambda, how you can configure trigger for it, and how it is very easy to like see. Normally, if I think if you don't have AWS Lambda, what you do, you will write any Flask code or anything, then you'll schedule it using some tools, and you will also provision infrastructure for that. With AWS Lambda, it's a lot easier. We wrote the code, we created zip file, we uploaded it, we also created triggers, and it is now simple. Now our task is done. This is all. In the next video, we'll see we are going to utilize this JSON file, and we will try to convert this JSON file to the Parquet file using AWS Glue. So this is our input file location. So this is our input file location. This is our data that where we have data. So we will create another bucket, let's say, and there we will try to get the data from here and we'll convert them into the Parquet format. So we will see in the next video what we are going to do. With this video, at least you now know that how we can download the data. So this is all we need. Thank you. Have a great day ahead. Bye bye. Hi everyone. My name is Avnees, and in this video we will see an overview of AWS Glue. So AWS Glue is a cloud optimized ETL tool. ETL stands for extract, transform, and load. Now you have clear idea about like why to use AWS Glue. So if you are building any ETL pipeline in cloud, if you're using AWS, so AWS Glue is a choice that you can opt for. Benefit, like if you go for AWS Glue, what benefit you will get? So first thing is that it's serverless. Serverless means what? You don't have to provision server or maintain those servers from your side. Whenever you want to run your pipeline, you can just run your pipeline and required infrastructure will be provisioned for you. Your pipeline will be executed, and once your pipeline will execute completely, it will be automatically shut down. So you only need to pay the time at which your code will be running. So that is the advantage of using AWS Glue. Second advantage, schema inference. So AWS Glue provides crawler for schema. Okay, so what you can do in AWS Glue, you can create a crawler, and this crawler can connect to any data source. So you can have S3 bucket. So let's say we have this S3 bucket. Here you will have semi-structured structured data like CSV file or a JSON file. You can have that JSON file. Then you can connect this data source to the crawler. So crawler can automatically generate metadata information, and those metadata information will be stored in AWS catalog, Glue catalog. So there will be a catalog basically to store metadata information about your data source. So metadata information. So what crawler does, crawler like scrape through your data sources and generates metadata, and those metadata will be stored into catalogs. And using this catalog, you can query your data sources, or you can do analysis on your data. So that's the advantage of using crawler. So you don't have to explicitly specify like what schema you have in your data sets. It can automatically uh, scrap through your data, and it can generate metadata information about like what kind of file you have, what columns are there, those things, and those things will be stored in the catalog, and later you can use it to query your data source. So this is the benefit of using crawler. Okay, now we will discuss. Now let's one and last thing is that you can create a job. So job is nothing but it's just your ETL pipeline. Okay, ETL pipeline. So this job you can run it, and we will see in detail when we will start implementing the project. In the next video, I'll explain you the requirement that we will be working on, and how we are going to design this ETL pipeline in AWS Glue. Everything we will discuss in details. I hope you got at least a brief idea about AWS Glue right now. And this with this we can start with AWS Glue. So this is all for this video. Thank you. See you in the next video. Hi everyone, my name is Avnis, and in this video we will understand the requirement for ETL pipeline that we are designing. So let's understand that in detail. So as per the previous videos, you know that we have this APIs, web API, from where we are downloading the data using AWS Lambda. So we are using AWS Lambda, and we've stored those record into S3 buckets. So, and even we have scheduled this AWS Lambda on weekly basis. So this was like one part that we have already completed. Now we have data in S3 bucket. So we have data in S3 bucket. Now what we want, we have this DynamoDB. DynamoDB. It's a NoSQL DB in AWS. So you don't have to maintain server, and you can still get a NoSQL DB. You can explore a little bit more on DynamoDB if you want to go in detail. It's just NoSQL DB. If you know MongoDB, it's similar to that. So in so what ETL pipeline we are going to design using AWS Glue. Using AWS Glue, we're going to read files from here. Okay, we're going to read files from a S3 bucket, and we'll store it into DynamoDB. So that is the requirement. So we'll design our pipeline here, ETL pipeline, and we will store the record into DynamoDB. This is what we are about to do now. Let's understand like what ETL pipeline we will design. So as per the ETL pipeline, so the steps will be like we have data in S3 bucket. So first of all, first steps, we'll read the data. We'll read data from S3 bucket. Second, we will also read data from DynamoDB. Read data from DynamoDB. Now we will have these two data sets. So let's say this is data set 1, this is data set 1, this is data set 2. Now we have to verify. Third step, check. We have to check, okay, how many records from DS1 is available in DS2, because don't want to insert duplicate records. Okay, so we wanted like we have this data in DynamoDB, this data in S3 bucket. So we have to check from in S3 bucket how many records we have that is already exist in DS2. So in fourth step, what we will do, we'll discard available already available records. Once this is done, fifth and final step will be, we'll try to insert new records. Okay, insert new records into DynamoDB, records into DynamoDB. With this, I think you got the brief idea about it, like how we are going to like what ETL pipeline we are about to write now. And one last thing that I wanted to discuss, the folder structure in S3 bucket. Yeah. So in S3 bucket, we will have a bucket. So within this bucket, we'll create inbox folder. Within this inbox folder, we will have some file, some JSON file. Okay. So every week we will have some JSON file in inbox folder. So whenever we will run ETL pipeline, this is going to read files from here. And once this newly any new record that we have found in this JSON, we'll try to dump those record into DynamoDB. Once record is inserted into DynamoDB, so this ETL pipeline is going to archive this. Okay, we will have one archive folder with it is going to move this file to the archive folder. So every time whenever we run ETL pipeline, if there will be any file here, those file will be processed and stored into DynamoDB. And once this operation successful, so the file that was processed will be moved to the archive location. So you will have all the files that you have processed through your ETL pipeline into the archive locations. And you already know that we are maintaining from date and to date. So in future, if you need to investigate like what was the file that was processed by ETL, you can go to the archive location and you can see the files. So you will have backup of files and you will keep on getting new files into the inbox location. You will process it using ETL, and then you are going to move those files to the archive location. So this is the ETL pipeline that we are going to design. I hope you got a brief idea about the ETL pipeline. In the next video, we are going to create some of the resources in AWS like DynamoDB that is required for us. So we'll create DynamoDB database. We have already S3 bucket, and then we can start working on our ETL pipeline. This is all for this video. Thank you. Hi everyone, my name is Avnis, and in this video we are going to provision AWS DynamoDB. I will log into my AWS account. We have logged in into AWS. So search for DynamoDB. It's a managed NoSQL DB. So in this we have to just create a table. Within that we wanted to store the information. So let's create a table. Specify a table name. So we'll just write a it is like the data that we have downloaded. It's a complaint about financial product. So we can give name as FC, like financial complaint data. And then it is going to ask you the partition key basically it is like a primary key. So you might if you have worked in RDBMS, so similar to that, this partition key is like primary key. So in our data sets we have like this complaint underscore ID, this column which will have unique number. So we will configure this complaint underscore ID as a unique key. Then it is going to ask you the sort by. So every complaint is regarding some product, so we'll try to sort it by product. But this complaint ID, it is a numeric field, so we'll try to choose number. So this is what information we have to fill for DynamoDB tables. So all this information has been set properly. Now by default this is a like read capacity and write capacity. It is specify like how it basically like improve, like if you give more number, so it is going to improve your throughput for read and write. So with this we are done with like basic detail that is required to create your DynamoDB. So let's hit create button. So within some times it is going to create our DynamoDB table fc underscore data. So this was all for this video. In next video we'll try to go through AWS jobs. There we will try to read the data, the pipeline steps that we have discussed. We'll try to implement them. And this is all about our ETL pipeline. Thank you. See you in the next video. Hi everyone. My name is Avnis. In previous video we have created this DynamoDB table fc underscore data. So it has been created successfully. In this video we are going to create an AWS Glue job. So we'll search for Glue. Okay, so we have just opened the dashboard for AWS Glue. So I was talking about the crawler. I have given you the definition, so you can create a crawler, and so you can just read it about a crawler connects to data source, progress through prioritize list of classifiers to determine the schema for your data, and then create metadata tables in your data catalog. So this is a section where your metadata informations will be stored. So within this table you will have, like if you create a crawler and it is going to scrap information, this is going to store those information into the tables or maybe databases. So these databases, if so right now they have not, like we have not run any crawlers on data sources, because of that there is nothing. But and we are not going to use crawlers for this project, because we know like a schema for our dataset, we are going to directly write a custom ETL job in AWS Glue. So to write your job in AWS Glue, we have to come into this section, data integration ETLs. So there is a link for AWS Glue Studio. We can open this AWS Glue Studio. Now we are inside the AWS Glue Studio. What it offers to us, so it visually create job flow and monitor their performance. AWS Glue Studio is an easy to use graphical interface for creating, running, monitoring AWS Glue ETL jobs. These things I think you already know what we are going to do here. So first of all we are going to create a jobs. So create and manage jobs. So this is where you can create a job. So let's click on this view jobs. So here in, if you have already any created job, so you will be able to see that, but as of now you can see that we don't have any job. So we are interested in creating it. So we will take this visual with a source and target, because this is going to generate some boiler script. So with the help of that we can start easily. So we can just click on create. So this is going to show you some like even you can, like basically you can design your ETL pipeline just by selecting some of the data sources. You can see that they're like AWS Glue, data catalog, S3, Kinesis, Kafka, relational DB, Amazon Redshift. So there are so many data sources options from where you can read the data, and target wise also they provides lots of sources, like you can dump your record directly to S3 bucket or maybe Redshift, MySQL, PostgreSQL. So there are so many options. And if you are looking for something that is not there, then in that case you have to write custom. So we are interested in DynamoDB. You can see the DynamoDB is not there as a target, so we have to write our own custom script for that. For source also we have data in S3 bucket, but we will write our own code for Amazon S3 also. So this is going to show you the script. So as of now you can see that this script is showing us some error, because I'll just try to remove all these sources, because we are not going to use it. We are going to write our custom code. So now if you go to the script, you can see that this is a generated script which is given to us. So we'll try to write code in this script. So to write a code, we can just click on this edit script and we can click on confirm, and then it is going to allow us to write the scripts. I will discuss these things in detail, what code we are going to write. Let me just give you an overview of every tab, and then we are going to write a code definitely. So in job details, it is going to ask you for the name of job. So it is this job we are going to move data from data to DynamoDB. Move S3 data to DynamoDB. So this is the name which I have given for my job, and then it is going to ask you for the IAM role. So as you can see that we are going to read data from S3 and write data to DynamoDB. That means any role that you will choose, that should have this sufficient permission. So I have already created these roles. Okay, so I'm attaching this role, but if you don't have, like if you don't know like which role you have to use, so you can directly go to the IAM section. IAM. Okay. So within this, you can create a role, any name you can give. The way you can see that. So you can choose the service for Glue. We want to create, so you can choose Glue, and you can select this Glue. AWS service is fine. Then click on next. Then policy wise, you have to attach S3 full access. So you have to search for S3 full access. So we have to select S3 full, and then you also need to select DynamoDB related some policy. So DynamoDB full access. Along with that, Glue related some configuration. So like for Glue, we need like complete access. So we can search for that. So AWS Glue service role, AWS Glue console full access. There's other like you can just directly choose AWS Glue service role, this one, and then you can click on create policies. Then you don't have to create policy. Then you can click on next, and this is all information about our policies. You can give a role name, and then you can see that it has policy name as AWS Glue service role, AWS DynamoDB full access, AWS S3 full access. Then click on create role. So whichever name you will give here, I have already created it. Those you can just after creation you can refresh this drop down, and if you choose like you can just search for the created role, you will be able to find out, and then you can select it. So and then this type, this we will be writing Spark code, so I'll just choose type as a Spark. There are other options like Spark streaming. So we are not working on streaming data, we are working on batch processing, so we'll write Spark. Then it is asking for the which Glue version you want to work with, so we will be using Glue 3.0, support 3, Spark 3.1, Python 3. Python language Python 3. This is going to ask for the worker type, so we will be using 16 GB RAM. It's like a 4 CPU, and then request number of workers. So it like, if you know about Spark, so it works in distributed mode, so you have to specify how many worker node you need to use. So by default there will be 10, but you can definitely decide like how many worker you want based on your workload. You can change, we'll keep as it is 10. Number of retry in case of failure, how many times you want to retry your jobs, so that it may get successful in the next run. So by default there will be 3, but we'll just try to make it to 1, but it depends on the business scenario you are working on, and you can just update these forms. So all these details we have to provide, and so your script name will be this one. Yeah, so you can click on save. So it is going to save our information. So now our job is saved, and the code that we will write we'll see in the next video. This is job detail that we have saved. In the run, here is the option. If you click on the run, your pipeline will start running. Schedule wise, we can schedule it. We can create a scheduler. Like once our pipeline, we will build our pipeline. If it works successfully, we'll schedule it, and we'll make sure that like the way we have scheduled AWS Lambda, we can schedule this pipeline. So every week, new data will be downloaded into S3 bucket, and from there, this pipeline will run, and this pipeline is going to dump those records into DynamoDB. So this is what ETL pipeline we are going to build. So in next video we will discuss in detail like what we are going to write. So this is all for this video. I hope you got to know about like how to create a like ETL pipeline in AWS Glue. At least you got the overview. So I'll create it this pipeline. You can try to take any other use case. You can try from your side. Definitely you'll be comfortable. You'll be confident in creating AWS Glue pipeline. This is all for this video. Thank you. Hi everyone, I am Onis, and we have all like as you are aware about that, we have already built one pipeline in AWS Lambda which can download data into our this bucket. So I have just done slight modification. Instead of downloading data directly here in this location, we are downloading data into the inbox location. Just to make these modifications, basically you have to like we have created zip file. If you remember, we have created zip file. So let me Yeah. So if you remember, we have prepared this code in VS Code where I have written this Lambda function file and I have explained it in detail. But there will be small changes in line number 65. You have to write inbox slash and just save it. After that, create a zip file once again. So reveal in File Explorer. This was the code that we have prepared. So I'll just simply delete this zip file and we are going to create this zip file once more. And we will upload this zip file. Okay, so you can select your these files and then right click, then compress to zip. So this is going to create a zip file. Make sure that you have selected all the files. So once this zip file is created, I'll just rename it a little bit so that it will have a nice name. AWS function. Okay, function code. Now we have created this zip file. We'll just quickly upload it to the AWS Lambda. Let's go and try to upload it to the AWS Lambda. So let's search for the Lambda. So like we have created this AWS Lambda function. So download data. Trigger also we have created. So what we wanted to upload the code once more. So let's upload the zip file. We'll go to the location once. Let me just confirm like where this file is there. What's the location of this file? So it's in this project. Okay, D drive project, lambda function code. Yeah, so I'll just upload this file so that we will have updated code. And testing wise, yeah, this code is already tested, so it will work fine. There is no problem at all. Yeah, so I have updated the source code. So this is a modification that if you want you can do it, or manually also you can move your file. So let's go to the S3 bucket once again. So duplicate S3 bucket. What I want, like in your bucket, whichever bucket you are using, in your bucket there should be an inbox folder, and within that there should be some JSON file. If it is there, then it is fine. Then we can actually work with our source code. So now we have data in place. Let's go and try to work on AWS Glue. So AWS Glue. Yeah, in case if you don't have file into the inbox location, I will suggest you to create a folder inbox. Here is the option to create a folder. You can give a name and you can click on create folder. This is going to create an inbox folder. Then you can select your files and go to actions and click on this copy. Then this is going to ask you to the destination where you want to copy it. You can move to, you can just select your destination and click on choose destination, and then you can click on copy. So this is how you can manually move your file to the inbox location if you don't know. Coming to AWS Glue, let's launch AWS Glue Studio. View job. So if you know, we have already created a job, move S3 data to DynamoDB. Let's go inside that. So we have already created a table, Dynamo table. Let me again duplicate it. I'll just quickly go through this DynamoDB table. So DynamoDB table that we have created. So the table we have created, the name we have given is FC data. So this is the table. Partition wise, we have used complaint ID column, which will be a primary key in DynamoDB, and the number is a data type of this column. Then sort by, we are sorting it based on product key, and it is again string type. So this is what there. So let's go and try to write some code here to build our ETL pipeline. Okay, it's quite simple to write code here. So first of all, let's try to declare some variables. So right now you can see that my bucket name is data 327030. So I'll create a variable. So we are going to declare constants values. So let me declare the constant values first. Yeah. Declaring constant variables. So we'll declare a bucket name. So I'll create a variable name as bucket. Okay. This is my bucket name. Then we will also write DynamoDB table name. We'll create one variable that is going to hold our variable name for DynamoDB. So you know that our variable name is fc colon fc underscore data, finance complaint data. So let's try to store this fc underscore data. Yeah. Next, we also have to specify what is my location of JSON file. So we'll try to specify. So here we have written S3, this bucket name. Automatically the bucket name that we have given here will be updated here as it is a variable. Then inbox, within that we will be having file with JSON. So any file that has JSON extensions, it is going to read those files. Coming to next, we will also use OS module because we are going to execute some of the AWS CLI command after the execution. We'll see like what we are going to execute, but we need this import OS. You'll get to see like where we are going to use. So with this, we have declared all the constants variable that is required. Now you know that if you are building any application, so you need to have logger that to check the progress, like what is going on within your source code. So we'll first of all we are going to create a logger. So to create a logger, we can use like we have to use this glue context. Glue context provide a function get underscore logger. Using that you can get logger object. So what we are doing, we are getting logger object to log the progress. So with this line, we'll get the logger object. Next is that we have to now read the file. But what I want, like we are going to log this information that we using logger. I'm going to log it like started reading JSON file from this location. So when we will go through the log, it is going to like if we get to see this line, that means our code is executed till line number 24. Now using Spark, we are going to read the file. So it has Spark variable available with us. So using this Spark, we can directly read any file. So we are reading a data frame and this is a Spark data frame. Why I have given a name as a Spark data frame? Because in Glue we have like two kind of data frame. The one that is provided by AWS Glue that we call it as dynamic frame, and one from PySpark that we can call as a Spark data frame. Just to differentiate, I have given name as Spark DF. Next, coming to the next line, let's try to log one more additional information, that is logger.info. Typecasting column of Spark data frame to long type. Why? If you remember, we have given complaint ID as number, but we are not sure that whether this if I'm going to read this file, this JSON file using Spark, there is no guarantee that this complaint ID column will be in the format of number. So we have to convert that column to the number. So whatever we are doing, we are mentioning in the log also, so that we will be able to see the progress. Then we are writing the code. Now let me explain you like what I have written here. So we have taken this data frame, then using with column function, I'm selecting this complaint ID column. Then on top of this column, I'm trying to so in PySpark you can use this call function. This call function is actually present inside. So we have to import this call function. So from PySpark .sql import functions as f func. Okay, you can see. So within this function module, we will have call function. So we'll quickly call this one. So on this module, we are calling this call function. It as a parameter, it accepts complaint ID, and then it is going to select this our PySpark data frame column. Then we are typecasting using cast function. You can just pass the data type, like intended data type that you want to in whichever data type you want to convert it. So you know that we wanted to convert it into the numeric format. So the long type, basically it allows us to store larger number of values. Because of that I've written long type. So this we are done typecasting the values. Now I'll just quickly print the column that we have in this data frame along with number of rows we have in this data frame. Okay, so logo.info, so length, and then like this column in data frame. So we are first counting the number of columns that we have in data frame, and then what columns are there. Also, we are also calculating the number of rows that we have in the data frame. This is done. So we are able to successfully read our data and typecast this complaint ID column to the numerical format. Next, so as I told you that we will also read the data from DynamoDB and we'll check whether this data frame will have some record that is already available in the DynamoDB or not. So we'll make that comparison. So before I can do the comparison, we have to read the data from DynamoDB. Reading data from DynamoDB, it's quite simple. We can directly like this source code is already available in their official documentation, but I'll explain you like what we have written here. So this is a dynamic frame. Okay, you can say dynamic or DynamoDB frame. So using glue context, we have to call this create dynamic frame from option. So using this from option, we can specify connection type is like DynamoDB. Connections options wise, we can mention that a table name. This is the table name that I want to read, and these are the like throughput, read percentage, and split. So using this, we will be able to read our data frame. Now there is a two possibilities that if you are trying to insert record into DynamoDB, there is possibility that we are inserting record for the first time. So if you're inserting record for the first time, so if I will read it, so there will not be any records. So let's try to check that. So this dynamic frame, what I will do, I'll first convert it into the Spark data frame. So to convert your dynamic frame to Spark data frame, it's quite simple. You can call this 2df function. This is going to give you the Spark data frame. And this new Spark data frame is what, like we will compare this DynamoDB data frame as well as this Spark data frame, and we'll make the comparison and we'll see like what are the records that is not available, and we'll assign it to the new Spark data frame. So right now I'll just assign it as none. So let's say we have some record in the DynamoDB. So this count will not be a 0. So definitely if there is a record, definitely we will have some entry. So this count will be more than 0. So if this count is more than 0, it will come directly to this line number 42. Now we'll just try to quickly check how many columns are there and how many rows are there. So we'll just try to log it. Then we have to see, we are not interested in all the columns. If you remember, we have this complaint ID as a primary key. So I only need complaint ID from this data frame. So we'll select that data frame. So first of all, like both table has same column name. So I'll just quickly rename that column name. So we'll create like existing complaint is Spark df. So this is DynamoDB frame, Spark data frame that we have converted. We'll select the complaint ID. So see the operation that we are writing here, we are writing on DynamoDB, like the record that we found from the DynamoDB. Right now we are not using this JSON file that we have read here. So we have JSON records into this variable df underscore spark def. So just remember that. And this, if it is starting with dy, that means this is from DynamoDB. If it is starting with df, that means it is from the S3 bucket. Just you can remember like that. So from DynamoDB, we are selecting this complaint ID column. We are just renaming this complaint ID column to existing complaint ID. Then now we have this data frame where we have existing complaint ID column. Now what I want, we have to now match these records. Okay, so using a left join, we can easily match it. I'll explain you the logic, like how we are doing it. So we are taking our data from S3 bucket, then we are joining with this existing complaint Spark data frame, and we are specifying that we are doing join based on complaint ID. So we have renamed this existing complaint ID and then complaint ID. So this complaint ID and this existing complaint ID, nothing but they are same. Then how we are joining it, based on the left. Now we have if you know what is left join, so left join is like you will get all the record from your left table, and for the matching record from the right side, and non-matching record, for the non-matching record we'll get null values. Okay, yeah. So now, like if there is no matching record, okay, in this data frame, so for this data frame, in for the existing complaint ID, we will have null values. See, left join, if you just go through the left join, it's quite simple. Like you will get everything from your left. Okay, so we'll get all the rows from the left. So and from the right side we'll get all the matching rows along with non-matching rows also. For non-matching rows we'll get null values. So if there is matching rows, that means that record is already there, but if there is no matching row, that means the record is not there. So what we are right now interested from this join data frame, we have to find out wherever there is no record for the existing complaint data frame, okay, wherever there is null. So let's quickly write that as well. Yeah. So logger.info, number of rows after left join. So we are counting like how many rows we have after left join. Then we will have this new Spark df. So as I told you, from existing complaint ID, if it is null, that means those records are not available in DynamoDB, and we'll create a new Spark data frame. Then once we have this new Spark data frame, we'll quickly drop this existing complaint ID as it is not required now. So we'll drop it, and I'll just try to repartition it because we are running with 10 worker. So this data frame, I will try to set the partition to 10, so that each partition will be shared to each worker, and each worker will be able to work independently, and it is going to optimize our code. This is scenario one when we have data, but if we don't have any data, in that case we don't have to do any operation, so we can directly accept new data frame. So whichever data frame we have read it, we'll just partition it to 10, and then we'll assign it to the new Spark df. So with this, we have filtered out all the new records that we have in S3 bucket. Next thing is that we have to convert back this Spark data frame. As you know that this is Spark data frame, again back we have to convert it to the DynamoDB, like a dynamic frame, sorry. So we have to convert it to the dynamic frame. Let's try to convert that. So we have written log information like converting Spark data frame to dynamic frame. So in like dynamic frame, we are using dynamic frame, but if you are using dynamic frame, we have to import from AWS Glue dynamic frame model. We have to import this dynamic frame class. Along with that, we also have to like we have typecasted one column to the long type, so we have not imported that. I forgot to mention, but we also need to import this PySpark.sql.types import long type. Okay, with this we are done. Now we have created a new dynamic frame. So this dynamic frame we have to insert into the DynamoDB. It's again quite simple. It started writing new record into DynamoDB frame. So I'm just like writing a log. And before I start the writing, I just wanted to count it, like how many rows we have to insert. Then using glue context, like the way we have created dynamic data frame from the DynamoDB, we can use glue context, and using write dynamic frame from option, you can pass your this dynamic frame that we have created and accept type DynamoDB, and these options we have to just pass, and with this we are done. Like this is the step that we have to do to write the data into the DynamoDB. Now if we are able to insert record into DynamoDB, then we also want to, like if you remember, I told you that from S3 bucket, if file is getting processed, okay, from here, so there should be archive folder. Within that folder this file should be moved. So that will be our last step. So let's try to write that code, write the code for that. So we are starting again with the logger. Data has been dumped into DynamoDB. Now archiving file from input or inbox, source this one to archive location. Okay, now we have like s3 sync command, which is quite easy to run. So os.system AWS s3 sync, we wanted to sync this inbox bucket with the archive bucket. Once it is done, we will quickly remove the file from inbox. So to remove a file from inbox, from S3 bucket, command is quite simple. AWS S3 rm S3 colon bucket name and inbox hyphen recursive. It is going to make sure that if like this inbox has more folder, it will also try to wipe them. So with this, we are done with the development. I hope you understood. In next video, we'll try to run it and we'll see like how to check the logs, that log that we have written, how to interpret it, and if there will be any error, how to fix it. So this will be the agenda for the next video. So I hope you understood the source code, you understood the logic that we have discussed. Next video, we'll start testing this source code. Thank you everyone. Have a great day. Hi everyone, I am Avnish, and in this video we are going to run this code. Before we start, like we execute this code, we have to save it first. So click on save. So this is going to save our code. So our code has been saved. So I think there will not be any problem. Let's test it. So right now we have not yet run any times. That's why it's 0 count. Let's click on run job. So it has started the run. Okay, so running status, you can check like it is right now, it is running. And here in the CloudWatch log, you will have options to check the logs. So if we can click on all logs. So as of now, the log got generated. So if you know Spark, so there is concept of driver node and a worker node. So driver is responsible to submit the to assign task to your worker, and then worker is responsible to execute those code and report back the status to driver. So if you want to monitor your application, so this is a log stream that we have to go through. So you can see like what is happening. So you can see that the log that we have written. So you can see that it is saying that started reading JSON file from this location. So wherever you see this glue logger, you'll be able to see that this is the log that we have done. Okay, like typecasting column to Spark data frame, then columns that we have in our data frame. So you can just check it. Okay, so like number of records that we have in this file, like 33,000 records we have. Then just check it, like number of record that will be written to DynamoDB. It is around like 33,000 because we don't have any record in DynamoDB. So yeah, so it is going to start like data sync. So it is going to start like write the data directly to the DynamoDB. So it's working like it's right now it is inserting the data into the DynamoDB. We can also try to verify whether the record is coming here or not. So there is an option. Okay, so you can count the number of rows that we have. So this option, get live item count. So you can click on that. You click on start scan. So you can see that record is coming into the DynamoDB. Uh, if you want to check the record, so there is an option like explore table items, and you can click on run. So you can say this is the record that we are inserting into the DynamoDB. So with this, we have built successfully one ETL pipeline, and deployment wise, as I told you, this is serverless. You don't have to do any deployment. Deployment is done. So our task is already completed. So we don't have to do anything. Okay. So every time we have already scheduled our AWS Lambda. So from AWS Lambda, it is going to download the data, and from AWS Glue, it is going to read those data and store them into the DynamoDB. So I hope you like this project. Okay, so it is going to take time. So I'll just quickly cancel it. But this is all. If you're using AWS Glue, so I hope like this is going to give a brief idea about how to use AWS Glue to design your ETL pipeline. And every time if you want to run it manually, you can click on run, and if you want to schedule it, there is an option to create scheduler. You can click on create scheduler. You can specify like how you want to run your pipeline. So let's say I want to run pipeline on weekly basis, so I'll give the name as exporting data to DynamoDB. Frequency will be weekly, and it is going to ask you weekly on which day you want to run. So if I have scheduled it on like downloading data on Monday, I can run it on Tuesday. So start hour you can specify, you can keep as it is, no problem at all. Click on create scheduler. So scheduler has been created. Now you can see that we have scheduler. So on every Tuesday, this pipeline will automatically run and will check if there is any file here in this location. It is going to read those files and store them into DynamoDB. Also, it is going to check, do we have like it is also going to make sure that the record is not available in DynamoDB. Only then it is going to insert, and once data is inserted, it is going to move those data to archive location. So in DynamoDB, we can quickly check how many records we have now. As of now, we are using less like capacity right now, 1 unit. If we increase this capacity unit, it is going to increase the performance. Again, it is auto scaling based on the request and response, and we can also edit it a little bit to enhance the performance. So as you can see that right now we have set it to the 1010. You can write it to 1000. So if required, it can auto scale and it can use units, 100,000 units. Again, these are things like of tuning, so you can try out based on your data set, task or workload that you are working with. But the main task that we had, like, it's completed. So I will again in the next video I will show you like the result, because this is going to take the time. So next video, once this is executed, I will explain you the result. We'll go through these files and we'll see like whether the archive folder got created or not. This will be a assignment related video and conclusion related video. So assignment wise, like if you have gone through this entire video, so I hope now you're comfortable in writing AWS Lambda function as well as AWS Glue job. So what tasks we are assigning to you to try out from your side is this one. So basically, the way I have shown you that we can read data from any API and we can store it in S3 bucket. So similarly, you can take any open source API that is freely available, like this one, rapidapi.com. You can go through that, you can explore it. There are so many APIs available as of now. Let me go through that. So this is a rapid API, like millions of developers use this rapid API platform to build, use and share the thousands of APIs. So in this platform, you will get APIs to consume data. So you can take any free or APIs and you can download the data and store it into S3 bucket. That is the AWS Lambda function that you have to write as assignment number 1. And store it into S3 bucket. Now you have data in S3 bucket. So what I want, you have to move that data to Redshift, Amazon Redshift table. Again, it's not that hard. What you can do, you can just create, like, just go through the structure of your data that you are downloading. Based on that structure, create a table in Redshift so that you can store your S3 files. Okay, so like S3 files data basically. Now third thing is that create AWS Glue job to store or to move. Okay, now the way I have shown you, like we are moving data from S3 bucket to DynamoDB. Similarly, so you have this Redshift table, you have files in S3 bucket. So what you have to do as a task 3, you have to write a AWS Glue job. So this is going to read a file from S3 bucket and store it into the Amazon Redshift. So that is the task 3. Fourth task, schedule AWS Lambda function to download data automatically on a specific interval. So you know that we have done scheduling. So likewise, you can also do the scheduling for AWS Lambda as well as for AWS Glue job. So this is the assignment that I am expecting you to do from your side if you have gone through these tutorials. So I know that now you are very much comfortable in writing the AWS Lambda function as well as Glue job. So you can definitely write it. Conclusion wise, Yeah, so you have seen that how we are using serverless AWS cloud services to build our ETL pipeline. So what are the overhead that we haven't we don't have to, like, you have seen that we are not managing any server from our own side. Everything is there already freely available to us. So we are only going to pay for the time at which our code will be running. So this is also help us to save our cost. Also, we don't have to provision servers, so we don't have to manage its life cycle. So this is again one more advantage. So there are certain advantages of using ETLs too. So I hope with this video you are now comfortable in building ETL pipeline using AWS Lambda functions as well as AWS Glue. For to explore in detail, you can also check AWS Lambda official documentation as well as AWS Glue official documentation, AWS Lambda documentation, and AWS Glue documentation. AWS Glue documentation. So you can just check their official documentation. This is going to give you in-depth understanding. So you can just go through these tutorials if you're not aware about AWS Glue. So this is all for this video.